We're to write the expression here in exponential notation. That means they want it written using exponents. They do not want you to multiply all of these numbers. A quick review of that. For exponential notation, let's say you had the number 4 to the third power. What this means is that you have 4 times 4 times 4. And if they wanted us to solve this, we would multiply 4 times 4. That would give us 16. And then you would still have to, that would use up those two, but you'd still have to use this one. And 4 times 16 would be 64. Okay, that would use them up. Oops, excuse me there. But what I'm really trying to get at here is this is called the base. You do need to be familiar, comfortable with this terminology. And the tiny little 3 up here is called the exponent. Alright, you need to be comfortable with that terminology. Alright, so we have 8 times 8. That would be written as 8 to the second power. Alright. Times, let me see, 1, 2, 3, 4, 9 to the fourth power, and then you just have 1, 2 there. So 2, I could leave it like this, or I can put a 1 up here. This 1 is always understood to be there, whether or not it's written. But if you want to write it explicitly, that's fine. So this is written using exponential notation. Okay, let's see, the next one we'll take a look at here will be number 5. I'll make brief reference to the order of operations. It's always in play, and I'll go into a little more detail with the next few examples. But I hope you recall that exponents precede multiplication. So 4 to the third power. I'll solve that over here. That would be 4 times 4 times 4. We just solved this, so that's 16 times 4. Remember, we used those up. We still have to use this one. And 16 times 4 is 64, and we've used them up. Okay, so underneath 4 to the third power, I simply write 64, and then I bring down whatever I haven't used. I haven't used this multiplication. I haven't used that 2. Alright, and now it's simply 2 times 64 would be 128. Okay, it has to be done in that order. Let's see, we'll take a look at number 8 down here. And a quick review of the order of operations. First you have parentheses. I think I'll write it over here. Okay. First you have parentheses. Any grouping symbol at all. Okay. That can be parentheses. It can also be these square brackets. Right. It could also be those fancy looking things. In fact, even absolute value is considered grouping symbol. Okay, these are all grouping symbols. Alright, they come first. Then you have exponents, the next most powerful thing that shows up in mathematics. Then you have multiplication or division, whichever one you get to first, going from left to right. Okay, so to indicate that, I'll usually put a little arrow over it. That green doesn't look very green. And then you have addition and subtraction, whichever one you get to first, going from left to right. Okay? Now we'll follow this order of operations in solving this, and the order of operations is always in play. It never stops. How to say? It never stops being used. Okay? So within here we have parentheses. Within parentheses we have another set of parentheses, but there isn't really anything to do in there specifically because of the parentheses. these are really saying the 2 is going to multiply whatever's in there. Okay, but we can't do multiplication before we deal with the exponent. Okay, exponents come first. So 6 to the second power is 6 times 6. I'll simply put the result of that underneath, right where it came from, and then I'll bring down everything that I haven't used. I haven't used these brackets here. The 2, which is supposed to multiply. I think this pen's getting a little, let's get something a little sharper here. Our 8, this 2, and incidentally, a lot of people are going to be tempted to do a subtraction out here, but you cannot do that. A number next to parentheses means to multiply. This 2 is supposed to multiply whatever's inside here. Okay? And multiplication, as you see, precedes addition. So you're going to have to hold off on that addition or subtraction out there. Within parentheses, here you have a multiplication, so again, you have to do that before this addition. 2 times 36 will give us 72, and I'll bring down whatever I haven't used. Let's see. So this plus sign, well, I haven't really used it. The 8, the 2, and the 5. Okay, again, within parentheses, we'll do whatever shows up first. We have 8 and 72. Both are the signs are the same, so we add and keep the sign. That gives us a positive 80, and we'll bring down whatever we haven't used. This 2 is just trying to multiply whatever's inside, so rather than bring down these brackets, which I could, I'm just going to use a dot. All right. And my preference is to say -2 times 80. To me, it saves a step. So I refer to this as a -2 times 80, which would be a -160. And then I'll bring down whatever I haven't used, which is this 5. And then I'll just have one last step. The signs are different, so you subtract and keep the sign of the larger. This will give us a -155. I want to refer back to this step briefly. Alright, so if I have if I don't want to refer to this as a -2, if I just want to say 2 times 80, I can do that. It's not my preference, but you don't get the wrong answer. 2 times 80 is 160. So if you bring down everything that you haven't used, let me straighten this back out here. In this case, I didn't use that negative yet, so it would simply drop down. Okay, you'd still get a -155 for your final answer. But again, my preference is to include that, just say it's a -2 times 80. Alright, let's do another order of operations. We'll tackle number 9 here. Okay, you have 2 different sets of parentheses and these brackets way out here keeping all this contained. So within this set of parentheses I'll do something, and since this is a separate set, I'll do something over here. You cannot do this subtraction because multiplication comes first, and I'm going to say a -2 times +2 is a -4. Then I come over to this other set of parentheses. Within parentheses, you have an embedded set, so you go to your deepest set first. Signs are the same, you add and keep your sign. And now I'll bring down everything that I haven't touched. Let's see if we can keep this straight here. So the 57, our square brackets, the curve grouping symbol, 72, and this division sign. Again, our square bracket, the curved grouping symbol, and this is times 5. Incidentally, they put a dot here, but they don't need it. If you have a number next to a grouping symbol, that's math shorthand for multiply. Alright, now we repeat the process again. Everything up here is gone. You don't have to worry about it anymore. You just worry about this line now. Okay. Within parentheses here, the signs are different. You subtract, keep the sign of the larger. This leaves us with a 53. Within this set of parentheses, 3 goes in there 24 times. Incidentally, if you can't do that in your head, you just sneak off to the side and do your long division, okay? 72 divided by 3 goes into 7 twice. 3 goes into 12 4 times. And then you put your your 24 right underneath there, okay? And now I'm going to bring down whatever I haven't touched. These brackets, I don't really need them anymore. All I need is this negative between them. And again, these brackets, I don't really need them anymore. But I do need these curved ones times 5. I just bring that down. Because if I didn't have these curved brackets, I would be doing this multiplication first. Okay, but the brackets say I've got to do the addition or subtraction first. And with signs are different, you subtract, keep the sign of the larger. It's so easy to be off by 1 on these simple calculations. So I'm going to go, just to be safe, so there's a 9, 29, and it's going to be a positive. Okay, and yeah, that looks right. And now I'll bring down whatever I haven't touched, which is times 5. And 5 times 2 would be 100. Well, 5 times 20 would be 100. 5 times 9 is 45. So 145 is our solution. And let's see if we have time for one more here. Yeah, I think we can do this last one. We'll get in number 12 here. And this has absolute value. And it's maybe a little bit hard to read, but this is supposed to be a division sign out here, okay? That is division. Alright, this is our absolute value symbol, so it's a grouping symbol as well as basically an operation. Positive 2, negative 15. The signs are different. We subtract, keep the sign of the larger. That gives us a negative 13. And that's all I'm going to do on that line. It might not be real clear, but these are absolute value symbols. Okay, so I haven't used them yet other than as grouping symbols. So I'm going to bring them down. And then times negative 16 divided by our negative 4. This next step's not very exciting, but I'm just going to take the absolute value of negative 13. Absolute value refers to the distance from 0, so we don't end up with a positive or, well, we don't end up with a negative. This is 13 units from 0, so that becomes positive 13. I'll bring down whatever I haven't used. And then we have multiplication or division, whichever comes first. Positive 13 times negative 16 is going to be negative something. And let's see real quick. That's 18. Oops, sorry there. 6, 7. And what do we have? 8, 0. 208. So I simply put the negative 208 right there. Then I bring down whatever hasn't been used, divided by negative 4. I don't really need the parentheses. Negative divided by a negative is going to be a positive 52. So that would be the solution to that one.